Yeah, also, this is chapter 5, and it's going to be about exponential and logarithmic functions. And 5.1 is just sort of a little introduction with exponential functions, with much more to come on those in 5.3. So basically, what an exponential function is something of the form, and this book uses a little bit different letters than I'm used to, so I may stumble on the letters a bit. C is going to be our y-intercept, and then a is going to be the base. A has to be greater than 0, not equal to 1. And then what's different, we're used to going like x squared. This is sort of the reverse. This is the base stays the same, but it's the exponent that's going to be the counter. And the reason that the y-intercept is at c is if x is 0, remember anything to the 0 is 1, so you get 1 times c. So when x is 0, f of x equals c. We'll see that a little bit more when we do graphing here in a second. So these first couple are just using a calculator, and the which is pretty easy. The one thing you gotta be a little bit careful with is when you have the fractional exponent. My exponent key looks like this. Yours might have a y to the x or something. But when you're doing a fractional exponent, you need to open a parenthesis and then 1 divided by 3 and close the parenthesis. Otherwise, you're going 7 to the first and then dividing the whole thing by 3. So on the calculator, that will look like, get rid of that, 7 raised to the, and then parenthesis 1 divided by 3. And enter. And then you're just going to get this decimal. So that would be the equivalent of 1.91, 4 decimal places, so 29. This next one is e to the 4th. And what e is, it's this kind of funky number. It's e equals 2.718, goes on forever, never repeats like pi. It's an irrational number. And this is going to end up being the base of our natural log and our natural exponential function. Right now, you won't appreciate how awesome this is, but next quarter, 148, you're going to love e to the x because it's the easiest thing to work with. So right now, we're just kind of making friends with the calculator. So we're going e to the 4th, and if you go second function, if you look for your button that says ln, it might look like in, but it's ln. The second function of that is going to be your e to the x. We'll bring that in close so hopefully you can see. And then that opens this up, and then we just put our 4 and close our parenthesis. And so that should come out 54.5982. Okay, so this next part is graphing, and how you would see it on the test is a little different than how you'll see it on the homework. On the test, if I was going to have you graph, I would just have you, graph it just on a graph. On the homework, it's going to be like a 4-part multiple choice. So you can kind of use process of elimination on the homework to figure out which one's right, but do be able to draw this thing, just the basic 3 dots and good to go. So the easiest way to do these is just always plug in -1, 0, 1 for anything that we're going to see in here. As a reminder, 4 to the -1, remember that's the same thing as 1 over 4 to the first, so that's 1/4. So if you have something to the -1, it's always 1 over that. Anything to the 0, so 4 to the 0, that makes 1, and 4 to the 1 is 4. So our graph would look like 1/4, 0, 1, and 1, 4 right up there. So it should look something like that. And these things, by the way, if I put more negative numbers in, like if I put -2, it would be 4 to the -2 would be 1/16. Oops, 16th. If I did -3, it would be 1/64. So it's going to get closer and closer to 0, but it's not going to go down here. It's just going to kind of keep trailing in towards the axis. Same idea, but with a fraction. So I'll just do the same -1, 0, 1. So 2/3 to the -1. The way you do a fraction to a negative is you just flip over the fraction, and that changes the sign to positive on the exponent. So you can see this is 3 over 2 to the 1. So that would just be 3/2. Again, anything to the 0 is 1, except for 0. And 2/3 to the 1 would just be 2/3. So at -1, it's going to be 3/2, so that's 1.5. At 0, it's going to be 1, and at 1, it's going to be 2/3. So this one's trailing in the other way from the first one because of the fraction. Okay, and the rest of these I have you guys try in class. It's a pretty short section. So for number 4, we'll just do the same table, x, y, negative 1, 0, 1 are generally nice points. And it's just because negative 2 gets very, very, well, in this case, very large. And the other side gets very, very small very quickly. So these are usually the only ones that you can actually see on the graph. So 5 to the negative of negative 1 would be 5 to the 1. So that would be 5. 5 to the 0, so that's 1 again. And then we'd have 5 to the, in this case, negative. So the positive is the negative 1 now because of the negative sign. And that would be 1/5. So this one is flipped around because of that negative on the exponent. So pretend like I went through that point, but that's the general idea. And the reason this is the same as the last one is because I can write this as 1/5 to the positive x. So it actually could be written with that fractional base again. Here, xy. So this one's going to, so far we've had y-intercepts at 1. And so this time we're going to have a y-intercept at 3 is what this 3 out front is going to do. So if I put in my same points, negative 1, 0, 1, 3 times 2 to the negative 1. So 2 to the negative 1 would be 1 over 2. So that would make that 3/2. And then 0, so 2 to the 0 would be 1, but then times 3 is 3. And 2 to the first would be 2, times 3 makes 6. And if I put in negative 2, just to kind of see what this does, since this one's up here at 3/2, and then 3, and then 1, 6, just so to kind of put my mind at ease as where this thing's going to trail in, I'll go ahead and toss a negative 2 in there, and I get 3, and then this would be 2 to the negative 2, so that would be 1/4, times 3 would be 3/4. So it's not like it's going to go in towards 1 now, it's still going to go in towards the axis, it's just doing it at a little different slope. Okay, this one's almost the same, but it has a negative in front. So if I go negative 4 to the negative 1, that's the same thing as negative. So this negative out here is really like a 1 times 4 to the negative 1 is a good way to think of that. So then this becomes my 1/4, and then the negative 1 multiplies it and makes it negative 1/4. Negative 4 to the 0. So 4 to the 0 would be 1, but then it's negative, so negative 1. And then 4 to the 1 would be 4, and then negative makes negative 4. So that negative in front is going to flip our graph down around the x-axis, or it's called reflect about the x-axis. So something like that. And then this last one, that's e again. So we'll just do negative 1, 0, 1. Let me just show the calculator steps with one of these. So we're going to go 2 times e to the negative 1. So we'll have 2 and then times, and then second function ln again. And then that opens a parenthesis for me, so negative 1, so I just have to close the parenthesis. And then I'll call it 0.7, because it's not a very big graph. And then if we do the same thing with 0, oops. If we do the same thing with 0 and 1, e to the 0 would be 1, and then times 2 is 2. And then e to the 1 would be the 2.7, and then times 2 would make 5.4. So negative 1.7, and then 2, and there's that intercept again, and then 1 and about 5.5, 3, 4, 5.5. So something like that. And then these last two are very plug and chug, so it's just really about kind of making friends with the calculator. So $1,500 is invested for X years at 8% compounded quarterly. The future value that will result is represented by this equation, where S is going to be our future value. What amount will result in 11 years? Round your answer to the nearest cent. So basically, this is our future value, and they're telling us that the X is the years. So we're going to just plug the 11 in right there, and let the calculator do most of the work on this question. So 1,500, 1.02, and then to the 4 times 11. And so let me show this one. So we're going to go 1,500 and then times parentheses 1.02. The parentheses is actually probably redundant, but I already started with it, so I'll stick with it. And then raised to, and so I can go 4 times 11 in my head and just go 44. But if it was something I couldn't do in my head, you'd have to make sure to open a parenthesis there and then times the 11 and then close that parenthesis. Otherwise, you get raised to the 4th and then the entire thing times 11. And let's see, I got that number twice, so that's good. So this one came out 3,585.08. And then the next one is basically the same thing, except it's an equation compounding continuously. And so we'll see the sort of difference between quarterly and continuously when we get a little further in the chapter. Actually, I think it's another chapter down the road. So here they're just giving us this equation, and this one's going to involve E. So we're doing S equals 1,000 and then E to the 0.09. So this is $1,000 invested at 9%, compounded continuously. That's going to turn out to be the E. And then how much will be there in 8 years? So times 8 right there. And so again, for the calculator part, we would just have 1,000 and then times second function E, and then raised to, that raises it to for us, 0.9, and then times 8. And we get that. That's S equals 2054.43.